Hey guys, Danny here. Welcome to week 6 of creative coding. This week we're going to be focusing on data visualization, so bringing data into P5 and looping through that data and then visualizing it in some way. So data visualization is all about taking rows and columns of information, data, and values, and using visuals to help clarify the story inside the numbers. So as designers, most of you are comfortable with using Adobe Illustrator and the rest of the Adobe suite. In Adobe Illustrator, there is a tool called the graphing tool that allows you to easily create charts and graphs very quickly. This was actually my process as well. I designed hundreds of charts and graphs using Adobe Illustrator for one particular client. The main issue using this process was that there were maybe 5 chart styles for this job, but hundreds of data sets that were associated to those chart styles. So essentially, I was redesigning the same chart over and over and over again, just using different values, but the same design. So I decided to use code to automate this entire production process. And I basically just redesigned all the charts and graphs in processing. Now when I get a new data set, I just have to upload it to the custom program that I built and then output a PDF. I also designed a simple graphic user interface so you can change the width and height, the chapter that this chart is going to be in, and each chapter had a different color associated to it, so you just had to click them on and off, and then you could export the specific file name here. So before using Illustrator for this job, it would take about 5 weeks of production time. It cost a lot of money for all the manpower we had to hire to help us with it. And since all the data in Illustrator is manually inputted, there was bound to be human errors. Using processing, we went from 5 weeks to about 5 hours and had no additional costs or any errors since it's all automated. So as long as the data is correct, then the visualization would be correct as well. So there are many reasons why you should use code when visualizing data. Here are just a few of them. So you can make your own custom software. You can save lots of time and ultimately money with any projects. It reduces the number of human errors or completely eliminates them. You can do easy updates with your files. It can handle large data sets too. You can actually port in live data from APIs. You can add interactivity, you can add animation, and then you could add your own mathematical calculations and algorithms to take that data and pivot it into different views and look at it in different angles. So before we can visualize anything, we need to learn how to find data. So there are a number of open databases online for you to access, and these are called open data sets. And basically you can go to these sites like New York City data site, census.gov, baseball reference. The Guardian has a really great data repository as well, and you can just download any sort of spreadsheet that you want from these places. And there's tons of sources online for open data sets. So the best thing to do is just to do a online search with the topic that you're looking for, then add data or data set to the end of it, and you should be able to find some interesting and helpful stuff around that topic. So this gets a little bit more advanced, but a lot of websites and any company that has a web presence probably has an API associated to it. An API stands for Application Programming Interface that allows you to do a query to their database. For example, you can ask the New York Times API what the top 10 articles were from September 16th, 1987, or the Open Weather API what the temperature was in London every day last week. Then there are also a number of tools that help you collect your own data. There are wearables like Fitbit or Nike Plus. OpenPaths is an app that tracks everywhere you go. The Feltron Reporter tool is a kind of diary app. And then there's the iPhone health tracking sensors. Another great platform is Gyroscope. I think OpenPaths is no longer working, but Gyroscope allows you to track everywhere you go. The only issue with Gyroscope is that it, I believe, is a monthly fee. So all these options can potentially give you a number of data formats. CSVs and TSVs are tabular data sets. A CSV is a comma-separated value, and TSV stands for tab separated values. And what you can do with these is you can actually just open them up in Excel and do some analysis that way. And then there's JSON and XML, and those are usually used with like APIs. You get data in usually JSON, sometimes XML. And these are node-based data sets. So JSON stands for JavaScript Object Notation, and XML is extensible markup language, which is very similar to HTML. So for this talk, we will be mainly focusing on using CSVs because they are the most common and easiest to work with. So again, it stands for comma separated values. So for all the columns, it's going to separate them by a comma in the CSV. You can also export CSV files and import CSV files to and from Excel and Google Sheets. To export, you just go to Save As and save the file as a CSV format. So once you find some interesting data, then you have to analyze it and clean it up for processing. Here's some data from City Bike as an example of what you could potentially find. They give you a lot of information, and you probably won't use it all, or you might need to condense it in some way. So that's data cleanup, essentially, getting it in the right format and ready to be visualized. So for the City Bike example, what I did was made some calculations in Excel to calculate the total number of trips every month since the beginning of the program. So you should definitely do some visual tests as you go, from the data collection to the sourcing to the scrubbing to the analysis. Just visualize along the way just to gain some more insight, just because it's a lot easier to see what's going on with the data when it's in a visual format versus just rows and columns of numbers. So as you can see here, the winter months has a huge dip in ridership versus the warmer months in the summertime has a much higher ridership number. So there's a increase in the summer and a decrease in the winter. So especially these days, because data is a huge part of our life, it's very important to be as ethical as possible when it comes to the entire data pipeline, from collection to scrubbing to analysis to visualization. So here are 5 kind of bullet points to follow. So you have to be truthful. So be honest with the visualization, with the data analysis, with the data scrubbing and collection. The visualization should be functional, so it should be as clear as possible. It should be beautiful, so design should be highlighting the aspects of the information that you want to be more prominent. It should be insightful, so there has to be some interesting points that the user walks away with after viewing your visualization. And it has to be enlightening. There has to be some sort of aha moment for the user as well. So when you have the data and you understand the story and the numbers, you then have to figure out the best way to visualize it. There are a number of different ways you could visualize a data set. This is a great website, datavizcatalog.com. It has a catalog of a number of different ways of visualizing data, and it gives you a description of each chart type, as well as an example and sample data. So you should definitely check out this site and look at all the different chart types that they have on it to gain some insight in what you can use for a visual representation of your data. So Visually actually did a pretty amazing study taking 2 quantities and was able to find 45 different ways to visualize them. There's line charts, icons, dot matrix, pies, areas, shapes, values, and many, many others. So honestly, there's an infinite number of ways I could visualize any data set. The hard part is finding the best way to do that. But there are a number of chart types that work best with certain types of data. So bar charts are best for chronological data. Line and area charts are best for time-based and interval data. Pie and donut charts are parts of a whole and always have to add up to 100%. Node-based charts take network data and find connections. Dot matrix is categorical, and choropleth maps take geographic data and change the colors of the shapes based off of the numbers. There are a number of bad habits that designers tend to make. This is one of them. Having a number of charts on a page together that are similar. These all look the same, but the one on the upper right has a range from 0 to 50 when all the others go up to 100. So that skews the visualization and gives the appearance that the one that goes from 0 to 50 actually goes from 0 to 100. So you have to make sure that the axes values are all the same if these charts are going to be on the same design together. So I also see sometimes bar charts are extended for aesthetic purposes, like turning an American flag into a bar chart. Makes things more confusing rather than helpful because it skews the data again if you're extending the bars of a flag to be a part of a bar chart visually the bar is going to look longer because you have a flag graphic associated to it that's tied to it. So it just looks like it's going to be bigger than it actually is. And when values in a pie chart don't add up to 100%, that's a big problem. All pie charts should add up to 100%. So here are some examples of successful data visualizations. So Nicholas Felton is a designer and data visualization artist. For about a decade, he collected his own personal data every year for the entire year. And at the end of the year, he designed a personal annual report based off of the data that he collected. All the annual reports are beautifully designed, and even though it's his own personal data, it's very interesting for anyone just to flip through and look at. So here are some spreads from Nicholas Felton's annual reports. So this one shows everywhere he went in New York City, whether he was walking or taking the bus or riding the subways or taking a taxi, how much he spent on travel, what areas he was in Manhattan, and how frequently he went to different locations. Here's another spread that shows all of the photos he took, what he was listening to, what he was reading, everywhere he went. Every picture he took has geolocation on it, so he knows where he shot it, and generally how many photos he took based off of location and time of year. And then here's another one from Nicholas Felton's annual reports. This one is showing his just general activity, so how active he is throughout the day, and breaking it down into different activities like walking or listening to music or reading or driving or writing, designing, watching, or talking. Really beautifully designed, just basically a collection of line charts and bar charts, but the typography and the color scheme and the layout are all beautifully designed. Here's a node-based visualization by Jared Thorpe using New York Times data. So he did a series of these for each year in the 2000s, I believe. So this is 2001, looking at all the different stories in the New York Times and the main topics in those stories. So the size of the text represents how frequently that particular topic was mentioned. And then all the connections are how those topics are connected to each other. So Fathom Design is an amazing design studio based in Boston, and they do mostly data-driven projects. This is one project they did for the Nike Fuel Band, and it is visualizing one person's entire activity over the entire year. Pop Chart Labs is a really great design studio based in Brooklyn. They do these posters, these beautifully designed posters. So this is one that is a node-based visualization. It's breaking down the grand taxonomy of rap names. It's essentially looking at physical or metaphysical attributes. Then you could break off in age, skin color, size, and then from size you go to small, small to little. Then you have Little Wayne, Little Kim, Little Flip, Little Scrappy, Little John, etc., etc. So this is a node-based visualization. So Hint.fm is another design agency slash kind of art collective. And they do a lot of really beautiful stuff with data as well. This is a visualization of Wikipedia entries and changes for the topic of chocolate. So all of these lines are different additions or subtractions from the Wikipedia page. And if you look at this beautiful graphic here, it's kind of interesting. It's actually a Wikipedia war over two people disagreeing with an entry. So one person makes that entry, the other person deletes it, and then makes it again, deletes it, makes it again, deletes it, etc., etc. So it's basically a Wikipedia fight. This is the MTA subway map designed by Massimo Vanelli. I believe it was designed and used in the 1970s in New York City. This is in my opinion, a much cleaner design, easier to navigate design than the one we currently have, just because a lot of the unnecessary detail was stripped out and the background was kind of tinted back. Sure, it's not geographically accurate, but it's a lot easier for someone new, like a tourist, to actually read and see and navigate. So it's very geometric and very linear. So it's a lot easier to find where you are and where you want to go and how to get there. Here's another project by Hint.fm. It's real-time wind data visualization. If you go to the site, if you go to hint.fm/wind, you can actually see it in real time. And one of the cool things about this project is that there's a gallery. So you can go back and see what like Hurricane Sandy looked like at the time it hit the like New York City area. So this is really beautiful to see in real time. It's interactive. You can zoom in, zoom out, hover over certain areas and get more detail. So this is definitely worth checking out too. Here's a visualization that is also interactive and has really beautiful animation. It's by Pitch Interactive and it's called Out of Sight, Out of Mind. And it's basically visualizing all the US drone strikes in Pakistan from 2004 to 2013. So if you go to the site, you should check it out. It's really interesting to see its progression and the timing of the animation. And it's really interesting that they decided to use the color red, which is very powerful. And it's also very interesting to see when Obama took office in 2008, I believe, the drone strikes escalated significantly. So again, you should check it out. It's all interactive, so you could hover over each area and click on it to learn more. So the URL is on the bottom, and I'll also add it to the description on YouTube as well as on the class website. So data doesn't necessarily just have to be visualized. You could represent the data in many different ways. So one way would be using sonification, using sound to represent data. So this is a really great project by the New York Times that is using sound to represent the very small differences when it comes to people crossing the finish line during the Winter Olympics. So because those are like microseconds, milliseconds, it's really hard for us to visualize it, but for some reason it's a lot easier for us to hear those differences. If you go to the site and hit play, then it'll play the audio for each one of these people crossing the finish line. Here's another really great data piece that uses sonification to represent live Wikipedia changes and updates. Let's just go to this site real quick and you can listen for yourself. So the bells indicate additions, the string plucks indicate subtractions. Pitch changes according to the size of the edit. The larger the edit, the deeper the note. The green circles show edits from unregistered contributors, and purple circles mark edits performed by automated bots. You also see announcements for new users as they join the site, punctuated by a string swell. So this is a really great piece by Kyle McDonald. Unfortunately, it's not live anymore. He was the artist in residence at Spotify a couple years ago, and he created this project called Spotify Serendipity. And it's basically in real time showing you two people that hit play at the same time on the same song anywhere in the world, and then visualizing where those people are and what the song is on a map. So now we're getting into data art. So this is a great piece by Raphael Lozano-Hemmer. It's called Pulse Park, and it was actually on display in Madison Square Park in New York City, probably in 2005, I think. It was a little while ago. So let me play some of this. The entire park had lights set up, and then at the front of the park, there was this sensor that detected your heart rate. And when someone walked up to it and held onto the sensors, it detected their heart rate and started flashing the lights all throughout the park based off of that data, based off of their heart rate rhythm. And then when they release the sensor, the lights actually store the last 100 participants and flashes the lights based off of all that data at the same time. This is another project by Jer Thorpe. He was actually hired to help organize the names on the 9/11 memorial. So what he did was basically design a custom piece of software using processing to determine where all these names should be clustered and put together based off of a data set that showed how everyone was related. So if they were working together in the same company or on the same floor, or if they were related by blood, if they were brother and sister, or married or something like that, then that would group them together in that particular area. And then you can click and drag and kind of move people around based off of minor changes that you can override. All right, so when we talk about data visualization and P5, today we're going to be focusing on using arrays. We talked about arrays a little bit last week, but this week we're going to get into arrays in more depth. So again, just create a variable name for the array, set that equal to, and then brackets, you want to put in the values for essentially your data. So the data points in the array. And then you can pull out different values based off of their position. So 0 is the first position, it's going to be 19. We always start with 0 with coding. The second position is going to be 1, which is going to be 32. And the third position is going to be 2, which is going to be 87. You can also do variable name.length to determine how many values are in that array. So there's 3 in here. Then we're also going to play around with some data functions. So map is a data function we're going to be using to remap different ranges, essentially. Max and min are going to give us the minimum and maximum value in an array. The arc we're going to be playing around with for pie charts. Then you could use sort and reverse to sort and reverse your data. Then we're also going to be using the preload function to load in your data files, and then load JSON to get JSON data from like APIs or something, for example. We're also going to be using the table class to load in CSV files. With the table class, there is a load table function. There's a get row column, there's a get row count function, there's a get row, a get num, and get string to get those values. And there's also a get column count too we're going to play around with. All right, so the first thing that we're going to play around with is just an array of numbers and then looping through that to visualize it as a simple bar chart. So let's go ahead and open up P5 and start playing around with that. Okay, make sure that you're logged in. And now we can save our files. And the first thing we want to do is delete the draw function because we're not going to be using it. And let's create this week 6 bar chart. Okay. So now at the top, let's create our array, our data set basically. Let's call it var. You can just do numbers. It could be whatever you want. And then let's put some random data in there. Okay. So that could be any number that you want, any number of numbers as well. Now let's change the color mode first to HSB. Then we want to change the mapping for that to be 360 for the hue, 100 for the saturation, 100 for the brightness, and let's do 100 for the opacity as well. Let's do a background color. Let's make it white. Okay. And then we are going to just loop through all those numbers and draw a rectangle based off of the data in the array. So let's do a for loop. Var I equals 0. I is less than numbers.length. So we want to loop through it the total number of times based off of the total number of data inputs we have in here, total number of values we have in the array. And then we want to iterate, so I++. Now let's create a variable n for our numbers. And that's going to be numbers and then I, because we're going to loop through each one. So this is going to be 0 first, which is going to be 19, then 1, which is going to be 30, 2, 62, etc., etc. And now let's do a fill. I'm just going to do a red for now. Then let's draw our rectangles. So let's do I times 20 for the x. Let's do 0 for the y, 20 for the width, and then n for the height. Cool. So we got a bar chart, but it's going down. It also has stroke around it. So let's take the stroke off. Okay, cool. So we got a bar chart going down. What if we wanted to go from the bottom up? So to do that, we would have to go height first, which will bring us down to the bottom. Then we have to bring it back onto the screen, so we have to do height minus n. There we go. We have a bar chart. Let's also change the hue based off of the data point. So instead of 0, let's do n for the hue. So as it turns into a higher number, it goes further around the hue spectrum. So it's kind of stuck in the bottom left-hand corner here, and it's kind of small. So the next thing we want to do is play around with the mapping function to map it, to spread it out and make it taller to take up the entire canvas. So this is the mapping function we're going to be using. And basically what we're going to be doing is we're remapping a number from one range to another range. So we're going to use the map function. You pass in the value you want to remap, the original start and stop, and then the new range that you want to change that start and stop to. For instance, if we originally want this to go between like 0 and 100, if that's the original range, but we want it to go the full like height of the canvas, which let's say is 400, then we would say the value here, then from 0 to 100 is the original one, and then we want to remap it to go from 0 to 400. So this is what we're going to do for this bar chart. We're going to make it so it's the full width and the full height of this canvas. And so we're going to create a variable for n, a variable for our x, and we're going to use the mapping function, variable for the width of the bar based off of the total number of values in the array and the width of the canvas, a variable for our height, which is going to be using the mapping function as well. We can use a variable for y, which is basically just height minus h. And then we could use a variable for the color, for the hue, if we want to map it to be between 0 and 360. And then we just apply all those variables to the fill and the rectangle. Okay, so feel free to save this one and then duplicate it if you want to. I'm just going to work off of this one as is. So in our for loop, we have our variable for n, but let's create a variable for x. So for that, we're going to use the mapping function. And we're going to map based off of I, which is going to be 0, 1, 2, 3, 4, 5. And we're going to map that x value between 0 and numbers.length to go from 0 to the width, the full width of the canvas. Then let's create a variable for our width of the bar, for w. And let's just do that as width divided by numbers.length to get that value. And then we're going to do a variable for height of the bar, so h. And we're going to map that to be the n value. So it's going to be originally be between 0, and let's just do the maximum value in our array. We can use the max function for that, and then pass in the array to find the maximum value, which would be 89. Then we're going to remap that to be between 0 and height. And then another variable for y, set that equal to height minus h. And let's just do a variable for c as well. And let's map that value to be n is the value, 0 and max numbers to be between 0 and 360 for the full hue spectrum. And now for fill, instead of n, it's going to be c. And then for the rect, it's going to be x, y, w, h. Okay. So now it's the full width and height of the canvas. So if we were to change this to be like 600 by 300, for instance, it's going to all proportionally change based off of the width and height of the canvas. So mapping can sometimes be confusing for some people. So I'm going to add another link to the description on YouTube as well as on the class website that links out to another video that explains mapping in a little bit more detail. If you guys are confused about that, then I would suggest watching that video as well. So the last example only worked with 5 numbers. So let's say we have a much larger data set to play with. Let's go ahead and do that. So there is, if you go to the class website, there is an array of numbers that we just copy and paste. So let's do that real quick. So let's go to creativecode.dannewoo.com, go to week 6, and then here is an example array. So let's just copy all those numbers. So Command C, and then go back to our web editor, and then paste them in the array. Let's hit play. So now we have a bar chart with a lot more data. Just to show you an example of how you update this with new data sets, it automatically resizes based off of those data sets because we are using mapping and changing the width and height and positioning based off of the width and height of the canvas itself and based off of the data and the total number of values in that data. So this data is actually data around elections. So that's why there's a peak every 4 years. And then every 2 years, there's a little bit of a peak. And then I think this was 2008 when Obama was elected. So these are all national elections, essentially, in the United States. So let's say we wanted to not do a bar chart. Let's say this is actually time-based data, which makes sense to do a line chart instead. So instead of using a rectangle here, we can say, okay, I'm going to comment out the fill and the rect and the no stroke. And then I'm going to add a begin shape above the for loop, and then an end shape after the for loop. Then inside the for loop, let's add curve vertex points. Then apply X and Y. So now we have a line chart. We could also do something a little different if we want to do like a scatter plot or something. So let's comment out the end shape, begin shape, and the vertex points. Add the fill back. And let's do an ellipse. X and Y. And let's just do 2 by 2. Okay, so it's got the stroke around it. Let's uncomment no stroke. Cool, it's a little hard to see, but those dots are there. Let's make it a little bigger. Let's try 5 by 5. It's a little better. So this is like a scatter plot, essentially. So just by changing the elements that we're using to draw with the data, we can do a bar chart with rectangles. We can do a line chart with the curved vertex points. And then we could also do a scatter plot with an ellipse very quickly. Then another thing that we could do is play around with the sort function and the reverse function. So let's do the sort function first. So above this, I'm going to say numbers, which is the array at the top. It's called numbers. And then I'm going to redefine that to be, let's do sort function, and then add the numbers array in there. And then it should sort this from highest to lowest, I believe. Sorry, lowest to highest. So it's sorting the data from lowest to highest here. If we wanted to, we could also do numbers equals reverse. And then numbers. And then this should reverse it to go from highest to lowest. There you go. Cool. So those are two functions that you could play around with as well. Sort and reverse. Okay, so we talked about line charts, bar charts, scatter plots. So another thing that we could do with P5, well, we could do really anything with P5, but another thing that we're going to talk about is doing a pie chart. So you could do a pie chart using the arc function, which allows you to pass in an X, a Y, a diameter for the width, and then I think a diameter for the height, a start angle, and an end angle for the pie piece, essentially. So if we wanted to make something like Pac-Man, this is what we would apply to this function. It's placed in the center of the canvas, so width divided by 2, height divided by 2. The size is just 200 by 200. And then the start radian is 30 degrees. So I think it starts here. So I think this is 0, this is 30, and then goes around to 330 degrees. So for a pi, let's just use this data for this pi, and we're going to loop through that and basically create an arc every time we loop through it, and then update the last angle to be the last angle plus the current data point in the for loop. So let's go ahead and do that. So let's go ahead and save this and create a new sketch. Let's delete draw, give it a name, week 6 pie chart. Create a data set, var, call it numbers again. Then I am going to create the same data set that's in the slides, so feel free to do this. 30, 10, 45, 35, 60, 38, 75, and 67. So that's going to be our data set. And then let's do a color mode and setup for HSB, 360, 100, 100, 100. Background, color, let's just do it white again. Let's do no stroke. And then we want to create a variable. Let's create a variable for our diameter. Set that to 300. And let's create another variable for last angle, which will be updated each time we loop through our for loop. But we're going to start at 0. Now we want to create a for loop to loop through our data. Var I equals 0. I is less than numbers.length I plus plus. And just like before, let's do variable n for numbers in the array. Numbers I. And let's do a variable for C. Let's change the color for, let's map the color based off of the data from the largest number in the numbers array to be between 0 and 100. And we're going to apply this to, this time, the brightness, not the hue. Let's do a fill. Let's make it, let's try red, 100 saturation, then the brightness is going to change based off of the data. So the larger the number, the brighter it's going to be. The smaller the number, the darker it's going to be. Then we're going to use the arc function. So the x and y is just going to be in the center of the canvas. So width divided by 2, height divided by 2. And the diameter is going to be the diameter variable. And then the start angle is going to be the last angle. And the end angle is going to be the last angle plus radians n. And then after the arc, we want to update last angle. Plus equal is taking the existing value for last angle and then adding the new number value in radians to it. Okay, so that should work. Cool. So we have a pie chart. So starting here, I believe, and then, so this is 30 degrees, this is 10 degrees, this is 45, this is 35, and this is 60, this is 38, this is 75, and this is 67. So it adds up to a full 360 degrees. So most of the time when you're working with data, it's going to be in some sort of spreadsheet format, most likely, like a CSV file. So for P5, it's definitely possible, and we're going to do this, to load in a CSV file using the table class. So this is what we're going to do. We're going to take in a CSV file, upload it to P5 to our root directory, load it to a table, and then basically do the same thing we did with the array, just loop through the rows and columns of that data, and then we're going to push it to an array here. So that's the first step. We want to get this data into an array that we could use, and then we can visualize it after that, doing the same process we did before, essentially. So let's do that first. So if you go to the class website, again, for this week, there's example data that you could download as a zip file. So let's do that together real quick. So let's go back to the class website, creativecode.danny.com, and go to week 6, and then click on example data. And that should download a zip file with some CSV files that you could play around with. So let's just save it to our desktop. So here is some CSVs that we could play around with. So this is city-back data. This is city-back data based off of months. And then we're going to play around with some word bubble data as well. And then here's some New York City weather data that you can play around with. So let's play around with the daily CSV file first. Okay, let's go back to the web editor. Okay, let's save the pie chart. Let's create a new sketch. Call it week 6 CSV. Delete draw. And then the first thing we need to do is upload the CSV file to our root directory. So I'm going to upload a file, and then you can click and drag it to this upload area. And once it shows up here, then you know you're good, so you can close this. And then the first thing I want to do is load in that data. So I'm going to create a variable for the values that we're going to create an empty array for, and then push that data into that array. And then let's create a variable for our data, which we're going to preload. And we're going to use the preload function. And we're going to load that table, that CSV file, and apply it to the data variable that we created. And we're going to load in the CSV file by its name. So let's just copy and paste it so we don't make a mistake. And this, as long as it's in the same folder, all you have to do is reference the name of the file. And then you have to define it as the CSV, because I think you could also load in TSV files and other file formats. And then you can also say there is a header in this data, which there is. In our setup, let's just do no stroke. Let's do color mode, HSB, 360, 100, 100, 100. And background color of white. You can close this window on the left-hand side too, just so we have more space. And then the next thing I want to do is loop through the data. Actually, let's just print out the data first. See what it looks like. So if you print it out to the console, you can see that it is a JSON data format broken into columns and rows. So the column is usage and the rows are the data underneath it and the values. So let's comment out print, and we are going to do a for loop for var I equals 0. I is less than data dot get row count, which is a function that's a part of the table class. It's getting us how many rows there are essentially, and then I++. And then we could also loop through the columns too. So there's only one column in this, but it's probably good to set it up in case there's multiple columns. We're going to loop through that, var j, because you can't use the same variable name for a double for loop. So we have to use j or something else. 0 and j is less than data.get column count, which is another function that's part of the table class, and j++. And then we're going to push all the data points to this array. And to do that, you can reference the array values and then say dot push data.get the number in the row and column. And then after this double for loop, let's just do another print to see that the data is in there for values. Cool. So we have data in that array now that we can loop through and use. I don't know what this sep is, but we can ignore it since it's not an error message. So now that we have it in an array, we can just loop through it like what we were doing before. So let's go ahead and do that. So after this print, let's comment that out too. Let's create another for loop. Because this for loop is below this one, I think you could use I again. It might give you a warning, but I think it's okay. And then I is less than values.length I++. And then same thing we did before, var n equals, in this case, values I. Let's have the bar chart. Let's make a bar chart, but have it go in a circular formation. So let's create a variable x width divided by 2. Variable y height divided by 2. Var for the width of the bar, let's make it 1. Var for the height. Let's map this, but let's do a negative mapping for the height. Now let's create a variable up here for inner circle and set that to equal 30. So we're gonna have this loop around in a circular formation, but also have like an inner circle so it's not touching at the center point of that circle. And sorry, for the height, let's do the value for n and 0, and then again max in values, and then 0, and let's do height divided by 2 minus inner circle. And then let's do a variable for the radius, r, and let's map that as well. I 0 and the number of values in the number of data points in the values array be between 0 and 2 pi, which is 360 degrees basically. Then var for the color, C, let's change the color as well. Let's remap that to be based off of the data point between 0 and max originally, to go from let's do a range between 120 and 360. So it's going to stay in the like blues and purples. Then let's add our fill at the top first. C 100 100. Let's do a push and pop because we're going to translate this. And we don't want it to affect everything in the array multiple times. And we're going to translate on X and Y. We're going to rotate around a circular format for like a circular bar chart based off of R. And then we're going to draw the rectangles. So 0, negative, inner circle for the Y, and then W and H for the width and height. All right, let's see if that works. Looks like I spelled inner circle wrong. There we go. So we have this, it's essentially a bar chart, and it's just going in a circular formation, but it's just a little bit more interesting than just traditional bar chart. So let's say we wanted to try this with another data set. Let's upload the monthly usage as well and the New York City temperatures as well. So I'm going to go here, let's upload both of those. Okay, looks good. So now all we have to do is change this value to be the name of, let's try the monthly first. Cool, so this is monthly. And let's try the weather data for that year as well. There's the weather data. So we have a template essentially that we could upload multiple data sets to and visualize and then export if we wanted to. All right, let's say we wanted to do something that had multiple columns in it, like a label column and a value column. So we have this Moby Dick data that is basically a word count for the total number of times like whale was mentioned in Moby Dick or ship or sea. So for that, we can do some sort of like word cloud or something. But there's 2 columns in there, so we have to load in 2 columns and push those 2 columns worth of data to 2 different arrays, essentially. So let's play around with that too. Let's go ahead and save this and create a new file. Delete draw and give it a name. Let's do week 6 and Moby Dick. So the first thing I want to do is upload the data. So we're going to use the mobydick.csv file. And the next thing we want to do is create a variable for our arrays to say we want the words and we want the values. So the words column and the values column. And another variable for just the data. Then we want to preload this. It's always better to preload larger files. We're going to load in the table. It's a CSV. There is a header. So now in setup, let's do no stroke. Because you don't really need that since we're going to be using text, but it's okay. Color mode. Do HSB. 60, 100, 100, 100. Background. Let's do black this time. All right, so now let's create our for loops again to loop through the data. So var I equals 0, I is less than data dot get row count. And I++. For loop, for inner for loop, var j equals 0. J is less than data dot get column count, j++. So then we're going to add a simple if statement. So if j equals 0, it's the first column. And words, we're going to push those values, push data.get string, since this is text, and I and j. And if j equals 1, then values.push, pushing the values column, data.get num I and j. Let's just print this to make sure that the data is getting in there. Print words. Sorry, let's change this to words instead of word. Play. Okay, so then we have our array of all the words. Let's try the values. Looks like we have all the values too. Looks good. Okay, so it looks like we are good to move on. So the next thing we want to do is play around with applying let's do the size of the text will change based off of the value of the word. So let's comment this out and let's do a for loop. And let's do var I equals 0. And then let's just loop through the first 20. And I plus plus. So let's create a variable for W equals words I. Create a variable for N for the values I. Create a variable for our Y value. Just make that in the middle, so height divided by 2. Variable for our size of the text. And let's map that to be N between 0 and max values initially to be between 0 and 50. And then let's do color as well, C, and map that to be N 0 and max values between 0 and 360. All right, so let's do a fill for the text. C, 100, 100. Text size is going to be S. Text value is going to be W for the words, 0 for the X, and Y for the Y. And then we can translate each one based off of the text width, so they're not overlapping. For W, 0 for the Y. Okay, let's try that. Cool. We got a little word cloud. All right, so it looks like whale, ye, Ahab, whales are the top 4. It just keeps on going. Cool, looks good. Okay, one other thing that you can play around with P5, because it's web-based, it's a lot easier for us to play around with APIs. Again, APIs stand for Application Programming Interfaces, and allow you to get live data into your projects from third-party platforms like Facebook or Twitter, Instagram, or in this case, we're going to be playing around with weather data using the Open Weather Map API. So let's go ahead and go to openweathermap.org. And let's go to API first. So this is the documentation for the API. For any API, the most important thing to do is look through the documentation and understand how to work with the API. So let's read the first part. So it says, please sign up and use our fast and easy to work weather APIs for free. I like free. Let's do that. So the first thing you need to do is sign up. So make sure you fill in all this information here to create an account. Select all of these options that you need to create the account and then create the account. I'll go ahead and sign into my own account. So once you're signed in, you should see something like this. And the first thing, and probably the most important thing we need to get, is the API keys. So go to the API keys, copy and paste your default one. I'm going to copy it. And let's go back to the P5 web editor, create a new document if you haven't already. Let's delete the draw function, and at the top, I'm just going to comment out and paste in my API key. All right, the next thing we should do is take a look at the API documentation. So let's go back to the API, and let's go to API doc for current weather. So this is all the documentation for how you get current weather onto your own site. So there's an API call, which is just like a URL in here. And then you could pass in the city name, city and state name, city, state, country, and then the API key as well. So let's just copy this URL and go back to the P5 editor. I'm going to comment that out so we have it. So let's go ahead and let's copy this to the API key area. And let's do, so city name, let's just do New York. And let's copy that and paste it into a web page, see if it works. Cool. So we're getting data. So I'm going to copy that back and paste it there. And it looks like we need the HTTP as well. So this is going to be our base URL for loading in data for a particular city using our API key. So for that, let's create a couple of variables. Let's do a couple of cities. So I'm going to do an array of cities. And let's do San Diego, New York, and Honolulu. Create a variable for an empty array for the weather for each one of those cities. We could push that data into that array. Then we're going to use the preload function again to preload this API request. All right, so in the preload function, we are going to create a variable for our URL. And then we're going to pass in this URL all the way up to q equals and paste it into the URL variable. One thing that we actually have to change is that because we are using the web editor and it's using HTTPS, we have to add an S to the end of HTTP. So now it's HTTPS instead of HTTP. And another variable we're going to create called settings. And if you look at the documentation, you can see that there is a unit setting. And that's because by default, you're going to get a value that's in Kelvin, which is like a scientific measurement for temperature. So let's change this to imperial, which is Fahrenheit. So we're going to do add. So we're going to do and units equals imperial. Now let's create another variable for our API key, which is app ID equals and app ID equals, and then let's copy and paste that key after the equals. Now let's create a for loop var I equals 0. I is less than cities, so we're going to loop through our cities at length I++. And then var city equals cities I. So we're going to pull out each individual city from that array, weather, and then we're going to push the data we're getting back into this weather array and load JSON. So we're going to get JSON data from this API, and we're going to pass in the URL plus the city plus the settings plus the API key. All right, so let's make sure, let's just do a print for weather, for the weather array, and make sure that we're getting data. Okay, cool. So we have the data in here, and it's coming in as a JSON format, so JSON data. So if we go to each one, go to main, and then there's a temperature value here. So we can get that. And then you could also get like wind speed, cloud information, other weather data, coordinates of the weather station you're getting this from. So there's lots of data in here that you could play with. But let's just do the temperature data and the name of the city. Let's make this a little smaller. So now let's add a background. I'm just going to keep that RGB, it's fine. 255 is for white. And let's do a text size. Let's do a 224. Let's do a text alignment. Let's do it centered. And let's translate this to be in the center, width divided by 2. And Y, let's just do 50 or something. And then let's loop through all that data again. var I equals 0. I is less than weather.length. So we're looping through this array, I++. And then we're going to add the text. Let's do the name of the cities first. Then let's separate the name and the weather value by a dash. And then let's do weather I. So that's the data, the JSON file. And then we have to do dot to go further into like the children. So main and then temp is where the data lives for the temperature value. And then let's do 0 for the x and let's do 40 times I for the y. So it moves down essentially each time. Okay, let's hit play. Cool. So we got the weather data for San Diego, New York, and Honolulu. And this is live data. So this is the current temperature in these locations. Let's add another one. Let's try Paris. So it's a little chilly in Paris. So that's basically it for APIs. And that'll wrap up actually this lecture for today. Again, I will be adding links to all of these examples on the YouTube channel as well as on the class website, along with other links, helpful links. And like always, feel free to email me or Slack me with any questions that you might have based off of this lecture. I am around and I'm happy to help. But that's basically all I got for you today. So have fun with data and data visualizations, and I will talk to you in the next video. All right, thanks. Bye.